All right, so last day here, 60 to 70. Now, for this one, they want us to describe end behavior of a function. Okay, so basically they're saying, look at the equation, tell me whether it's going up, up, or down, down from the left and right, or is it going down to the left, up to the right, or is it up to the left, down to the right? If you want to know how to figure that out, you're going to be going to section 412. Okay, so 412, I have end behavior. Okay, so that's right over here. Okay, I'm not going to write this out for you guys, but look at your Google Classroom, go to section 412 notes, and that'll be there for you. Okay, that basically tells you if the degree is even, they either go up, up, or down, down. It's up, up if it's positive, it's down, down if A is negative. If it's a odd degree, then if it's positive, it falls to the left and it rises to the right. But if it's negative, the A term, then it rises to the left and it falls to the right. Okay? So that's the definition. We're not going to spend time going over that because it's going to take us like 5 minutes to do that. So again, section 4.12, write that down somewhere so you know where to look for it. So according to this, I noticed that my degree is, whoops, my degree is odd. Okay, so my degree is odd, and my A term is positive, right? The A term is this number that's supposed to be in front of the x to the fifth. Okay, so right here. So that number in the very front. So what we're going to do is, since it's an odd power with a positive A, that means that the graph is supposed to look something like this. Okay, meaning it falls to the left and it rises to the right. So it's going to be A. All right. Second problem, the degree is even. Okay, you can see it right here. And notice the A term is negative. So if it's negative and it's an even degree, so let me write this down here. A is negative. That means the graph goes like this. So it falls to the left and it falls to the right. So that would be B. No work really required. You don't even have to write down those things that I wrote down. I just wrote them down for you guys so that when you're looking over the problem, you're gonna see like, okay, he did something about the degree and the A term. Like, what does that mean? Look at section 412. It's gonna be there for you. Okay. All right. Sketch the general shape of this function. Now you might say, I have no idea how to graph a cubic function. Okay. Well, look, there's a couple things that you can do. First off, you're going to want to look at the y-intercept of that function. Okay? So the y-intercept is right here. So I'm going to write this down really quick. Y-intercept of -2. Now look at your graphs. Which ones do not look like they pass through -2 on the y-axis? Which ones do not look like they pass through -2 on the y-axis? A, B, and what else? Let me check. Yeah, so then what's your answer? There you go, you're done. Y-intercept is one of the most important things when you're trying to just sketch a graph, because it tells you where it's supposed to cross. Now, if there would have been 2, then what you would have done is you would have said, okay, now let me think about the end behavior. A power of 3 is odd with the negative A, so it should be rising to the left and falling to the right. And notice that's what C does, right? It rises to the left and it falls to the right. So that's kind of another helper for you. Now, let's look at this next one. What is my y-intercept for number 63? 5. Which ones do not look like they cross through 5 on the y-axis? A, I mean, maybe B, but, sorry, B might be okay. C, all right. D might, yeah, it might be D or it might be B, right? So it's 2 of them right now. I'll kind of zoom out, but those 2 are possible. So if my degree is, my y-intercept is 5, I just eliminated 2. So now I got to think to myself, okay, let me look at the degree. The degree is 2, right? How many turns is that going to have? Maximum. 1. So we said B and D. Which one looks like it only turns once? D. It can't be B. Has to be D. B changes, let me see, goes down, then up, then down, then up. That changes direction 3 total times. Okay? So it has to be D. So that's where that maximum number of turns comes in, right? When you're trying to figure out, like, okay, how many times is it going to go up and down? Look at your highest power and then subtract 1. Are we okay with those? All right. Now, 64 and 65, those are going to be, these next couple are going to be kind of tough, okay? So let's see. Let's see if maybe I can write them up on top because there's a lot of space up there. So 64 says that they want me to write an equation of least degree with integral coefficients with a given 0. So they gave me 2 answers, so let me write this down. 64, they said 2i and 3. Okay? So that means I still have another answer, negative 2i. Because every I has a positive and negative. Okay? So that means that my function is, I'll do x minus 2i, x plus 2i, and x minus 3. Remember, you always take the opposite of what's listed, right? So a 2i becomes a minus 2i, a 3 will become a minus 3, and a negative 2i will become a positive 3i will become a negative 3. Now, you'll notice I put the i's together because I told you guys that's the best way to do it. The easiest thing will occur if you do that. So, I'm going to multiply. Okay? Multiplying these right here. Oh, hold on one second. So, multiplying these right here. So, here we go. X times x is x squared. X times 2i is 2xi. Negative 2i times x is negative 2xi. And negative 2i times 2i is negative 4i squared. And then I got to multiply that by x minus 3 eventually. But notice this middle set is going to cancel. So I have x squared. What does negative 4i squared become? A positive 4, right? Because I squared is negative 1. So that's negative 4 times negative 1. So that becomes a positive 4 times an x minus 3. So again, I'm going to distribute. Okay? So I'm going to distribute those. Okay? And these right here. So let's see. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. 4 times x is 4x, and 4 times negative 3 is negative 12. There are no like terms, so there's my answer for number 64. If I would have not multiplied those two complex numbers together first, I'd be in a mess right now, okay? The total number of terms that I would have been trying to put together would have been 8 consecutive terms all in a line. But by doing those complex, it helps me do less. Yeah. So let's do number 65. Okay, 65, they gave me a negative 4, a 2, and a 1. So I'm just going to, let me write that out. Negative 4, 2, and a 1. So that's going to be f of x equal to x plus 4, x minus 2, x minus 1. Notice I don't write plus or minus 1, plus or minus 2. You don't do that with normal numbers, just the complex ones, the imaginary ones, okay? So this only has 3 solutions. So let's go ahead and start multiplying. Okay, so I'm going to multiply x times x, x times negative 2. And then I'm going to multiply the 4 and the 2 here. So here we go. X times x is x squared. X times negative 2 is negative 2x. 4 times x is 4x. And 4 times negative 2 is negative 8. And I'm going to multiply that times x minus 1. okay? So I'm going to combine the stuff on the inside. So that's x squared plus 2x minus 8 times x minus 1. And then I'm going to multiply again. Okay, I'm going to multiply everything out one more time here. So this x is going to go times those three terms. And then my negative 1 is going to go times these three terms. All right, so here we go. So x times x squared is x cubed. X times 2x is 2x squared. And x times negative 8 is negative 8x. Negative 1 times x squared is negative x squared. Negative 1 times 2x is negative 2x. And negative 1 times negative 8 is a positive 8. Now let's combine like terms. So x cubed doesn't have a like term, so that's good. My 2x squared minus x squared. These are going to be like terms right here, okay? Those are like terms. And then these right here, bless you, are like terms as well. So let's go ahead and do those. Negative 2x squared minus x squared, that's a positive x squared. Negative 8x minus 2x, that's a negative 10x. And then a plus 8. And there's your answer. Those are a bit of a hassle. But, I mean, they're not terrible. You're just multiplying, but they are a bit of a hassle to do. You okay with that? It's just a lot of distribution. A lot of distribution. All right, and again, these notes will be up there for you guys if you ever need to look at them again, or if you want to see the video again, that's fine. All right. Long division. Okay, so we got to do long division for, well, actually not for 66, but we do have to do it for 67. Okay, so let's go ahead and do 66 right here in the little space that I gave you. It should be enough. Since it's only one term that I'm dividing by right here, okay, only one term, then I'm going to divide every term by 5x squared. So here we go. 5x cubed divided by 5x squared plus 5x squared divided by 5x squared plus 5x divided by 5x squared. All right. So 5 divided by 5 on the first one is going to cancel. So x cubed divided by x squared is just x. Notice by now you probably know your answer is going to be b. That's my first term. Okay. If we keep going, we'll put a plus there. 5x squared divided by 5x squared, well, all that cancels out. There's just a 1 that remains, right? 1 over 1. So it's going to be 1. Okay, x plus 1. So again, you should know by now it's b for sure. But if you want to go one more step here, 5 divided by 5 goes away. X divided by x squared. That means there's 2 x's on the bottom. There's 1 x on top. That means only 1 remains on the bottom. So this is your answer. And like I said, it's B. Now, 67 was tricky to some people, okay? A couple of you guys got it right. A lot of people were kind of like, oh, I don't see the answer. Something's wrong. And I said, no, the answer's there. And they're like, I don't see it. So let's go over this one. We're going to do long division. Okay, you can do it synthetically, but there's like a step ahead. So we're just going to do long division for this. So 2x minus 2. And we'll have 6x squared minus 8x plus 4. So 2x times something is 6x squared. Well, that's going to be 3x, okay? So 3x times 2x, remember we're backward distributing, right? So 3x times 2x is 6x squared, and 3x times negative 2 is minus 6x. And I'm going to subtract, okay? I'm going to subtract these things. So the first one's cancel. Negative 8x minus a negative 6x is a negative 2x, and we drop down to 4. And all I need to do, I got to get 2x to become a negative 2x, so I'm going to multiply by negative 1, okay? So negative 1. Now remember, I'm just multiplying 2x minus 2 by negative 1. So that's going to give me a negative 2x and a positive 2. And I'm going to subtract. Well, negative 2x minus 2, negative 2x, sorry, is 0, and 4 minus 2 is 2, so that's my remainder. So my answer is 3x minus 1, I like to put a parenthesis, they don't, but I like to do that, and then plus 2 over 2x minus 2. And if you look, my answer is C. And you're like, well, it doesn't match. Okay? But it does match. You see this part right here? This piece? What number can I take out of the bottom? A 2, right? So that means this is really 2 times 2x minus 1. And can't I cancel out those 2's since they're the same? So if I cancel that out, this becomes a 1. That goes away, so this becomes 1 over x minus 1. And that's exactly what it says on C. So they just simplified the remainder. They said, oh, look, they all have a 2 in common, so let's cancel it out. All right? Weird that they did it, but it's not wrong. It's actually correct. If it's something that you can factor, they factored it, and they got rid of it. They simplified. Okay? So your answer is C. It just doesn't look like it when you do it. Just if you don't see your answer, ask yourself, was I supposed to simplify the remainder? Right? Because maybe that was the issue. So it is C. Any questions on that one? Just check something. All right, we got over 20 minutes, so we're fine. I was worried that we're running out of time. All right, so we should be done on time or before. All right, for number 68, I had you guys rewrite it, and I said, look, here's the new function I want you to do with the answer of negative 1. So we're going to do this synthetically, okay? So negative 1, and then your terms on the inside are 1, 1, negative 1, and negative 1. You'll add on top, multiply on the bottom, drop your 1, and then start multiplying. Negative 1 times 1 is negative 1. Then add, so 1 plus a negative 1 is 0. And then multiply, so negative 1 times 0 is negative 1. And then add, so negative 1 plus negative 1 is negative 2. Multiply, so negative 1 times negative 2 is 2, and add those together, you get a 1. How did you get a 1? Can anybody tell me? I just realized, because when I got a remainder of 1, I'm like, that's not right. It's supposed to be a 0. Where did I mess up? Yeah, my multiplication, right? Negative 1 times 0 is not negative 1. It's 0. Okay, so let me try that again. All right, I'll use the blue just so you can see the numbers that changed. So negative 1 plus 0 is negative 1. Negative 1 times negative 1 is 1, and negative 1 plus 1 is 0. Now, this actually, it's a good thing that I messed up. I mean, I messed up. I'm not trying to say I did it on purpose. That was a mistake. But it's a good thing that I messed up because it kind of shows you that as soon as I was done doing this process, I stopped and I said, I did something wrong. Because my answer, when I do these problems, my remainder is supposed to be a 0. Because I'm telling you that negative 1 is an answer. It's a 0, as we call it. That means my remainder has to be a 0. Mine came out to 1, and I said, wait a minute, something's wrong. Immediately, I knew I did something wrong. It wasn't like, oh, let me double check just for fun. No, I'm like, I need to double check because I messed up, right? Something is wrong. So, I mean, I guess a good learning experience here for you guys to see what happens, right? If you do it wrong, you'll be able to tell, all right? So anyway, we got it right this time. So since I started with an x cubed, this should be an x squared plus a 0x minus a 1. So that's x squared plus 0x minus 1. So that's going to be my factor, x squared minus 1. That's what I get from here, okay? And I should know how to factor that. That should be pretty easy. That's something squared minus something squared equals to 0. Well, x squared is just x squared, and 1 1 is just 1 squared. So my answers are x minus 1, x plus 1 equal to 0. And I'm going to go ahead and solve each one of those. Okay? So, excuse me, that's x minus 1 equals 0, x plus 1 equals 0. So add 1 to both sides. I get x equal to 1. Subtract 1 from both sides. I get x equal to negative 1. So here are my three answers. Okay, the three answers that I got are 1 and negative 1. And what was my other answer? 1, negative 1, and the one on the very top was, hold on, my thing is taking a while to respond here. Negative 1 as well, right? So I got two negative 1s. How do I write that? Negative 1, multiplicity of, yeah, mult 2, and then a positive 1. All right? So let me write that multiplicity thing again. But yeah, you're going to write multiplicity of 2. Whoops, don't want that. So mult. Okay, so that's how you do number, I don't even know what number that was. 68. So we got two more. All right. So for this one, the way I would recommend you do it is you're going to pick one equation that's given to you, and you're going to try to figure out which ones fit that equation. So I'm gonna try this equation right here. Okay, it's going to start at negative 3 on the y-intercept. Okay, it's going to start at negative 3, and then it has a slope of 4. What kind of line should it be? Solid or dashed? Solid line, and I'm shading which way? Above, right? Greater than or equal to. So, let's see. Part A. It starts at negative 3. It has a slope of 4 over 1. 1, 2, 3, 4, 1 over. So there it is. That's the right slope. But is my line correct for this one? No, this is a dashed line right here. Okay, it needs to be solid, so it can't be that. All right, let me look at part B. So when I look at part B, I try to zoom out. It's just the file's getting so big because I'm writing on such a large file that sometimes the program's like, whoa, hold on. So if I look at part B, here's negative 3 with a slope of 1, but does that line fit the description that I have to be a solid line? No, right? This is dashed, so it can't be B. What about C? Does that fit? Is that a solid line at negative 3, 4 up, 1 over? Yeah, but which way am I supposed to shade? Above, and this one is shading below, so it cannot be that one. So my answer has to be D, right? I have no choice. Has to be D. And if you check it, you can see right here, it's shaded above. It's actually the only one that does that. Okay? That's how you do these. Pick one equation and check it consistently. See if it fits. Okay? So, all right, let's look at this next one. So pick an equation. Let's pick the bottom one. It doesn't really matter, but I'm going to pick the bottom one, and I'm going to solve it for y. Okay, so 3x plus y is less than or equal to negative 4. So let's subtract 3x. So y is less than or equal to negative 3x minus 4. Okay? That's not going to be the nicest one, but I guess we can do it. I don't like the fact that it's going to go out of the graph. So that just means our slope is going to have to do the opposite, okay? Because notice if I'm at negative 4 right here, and I have to go 3 down, 1 over, that means I'm like 1, 2, 3, 1 over, right? Like I'm outside of the graph. So instead of going 3 down and 1's to the left, let me go 3 up and 1's to the right. So 3 up, 1, 2, 3, 1's to the right is right here. All right, so there's that line right there, okay? This line that's showing up, that's kind of going this way. All right. Now, my line is supposed to be solid or dashed? Solid. And that one is solid, the one I have the 2 dots on. I'm supposed to shade above or below? below, and this one is shaded below. So that one looks like it's doing what it's supposed to do. Let's check the other ones. If all the other ones don't do it, then we know the answer has to be A. So, all right. Starts at -4 with the slope of -3. Remember, I have to go backwards. So up 3 once to the left. Solid line makes sense. Is that one shaded below? No, this is shaded above. So it can't be that. Okay? All right, next one. -4 with a slope of -3. The line has to be solid. Is that one solid? No, so it can't be C. It's supposed to be solid line. One more. What's wrong with part D? It's shaded above, right? And that's not supposed to be above. So your answer has to be part A. So that's all you guys have to do.